It's a very simple message. In this case, it's a 17-byte message. Writes out one character, it's an unsigned byte, and it writes out a long as a notional timestamp, and then a double. So it's a very short message, really.
What Java version you use?
This one was Java 6, but it is built for Java 6, but it obviously runs in Java 7 as well. Now, one thing to notice about this, I reduced the heap to 32 megabytes, and I enabled verbose GC. As you can see, no minor collections at all. No collections.
I was wondering about the syntax when you tried. Looks like
that's the IntelliJ doing that.
oh,
It makes it look like a Lambda expression when actually it isn't. It tries to do some code faulting to be a little bit clever. So go back to this. So that's a low level interface. And deserialization, by the way, because it has to deserialize the values. You'll see in the next example involving an object, like a proper object, not just values.
There is a line of code that is used on C.
Yes.
Can you tell us a little bit about that? Only for benchmarks?
Okay, there's two modes. The default mode is it will use byte buffers. And byte buffers have all sorts of extra checks to make sure you haven't run off the end of the memory. And this is normal in Java to expect that if you try accessing a piece of memory that you shouldn't, you should get an exception. But what useUnsafe does is it bypasses all of that. It just accesses the memory directly. So this is useful for either benchmarks or code where you've tested it thoroughly, you know that won't happen, and you need that extra bit of performance. But in general, it doesn't help you quite as much as you might think, because often the bottleneck is the speed of your hard drive. Certainly your sustained speed will be based on your hard drive, and whether you switch that on or off will make no difference whatsoever. But in a test like this, it can make up, in real cases I've seen it make up to 30% difference, because it bypasses all the checks for byte buffer. Has everyone come across the unsafe class? Anyone come across the unsafe class? Right. Well, basically what this does is it effectively gives you a wrapper for the unsafe class, but it does it in such a much more lightweight way than byte buffer does. I'll show you. I'll show you the code for the unsafe class at the end. Okay, so what sort of performance can you get? Nice thing about it is that the performance keeps on going up to pretty much the limits of what your hardware can support, both your memory and your hard drive. So as long as you've got a decent amount of memory and a fast hard drive, keep on scaling up the number of messages you've got. This one was using an SSD, so the faster column. So you can see it was doing about 10 million a second, right up to 2 billion. And at that point, I ran out of disk space. So that's why I stopped at that point. The benchmark wasn't because I got bored. So this week I bought a much bigger SSD drive, got a 480 gig one. So I'm going to try that again next week. It's also faster as PCI one. So how does it do recovery? Well, once the finish returns, the OS will do the rest. That message will be saved. Your process can die at that point, and in fact, you can use unsafe to prove that by just calling, if you do unsafe get reference 0, your program will crash at that point, won't shut down, it just crashes. And you can check that that message was written correctly. If the exit is incomplete or you're in the middle of running finish, that message gets pruned. So you've got a very short window in which a message could be lost in the middle of writing, but if that's the case, it gets chopped off. It is naturally cache friendly because it's continuously packed. It's always appending to memory. And the first byte of a message is immediately after the last byte of the previous message, and they're all continuous in memory. So you get this caching behavior as well. How is the garbage collected? Well, the assumption is that you have some natural cycle in your application, say a daily or a weekly cycle. And at that point, you rotate the files, either by restarting the application, or you can rotate the files while the application's running. You can't read that very easily, but basically, it just means that you rotate the logs once a day and at a controlled time. And you may generate very large logs, but very few systems produce more than a terabyte in a day, whereas a terabyte hard drive isn't that expensive. Can you hide this low-level detail with an interface? Because it is very low level, and indeed you can. So there is a higher level demo application, which simulates two nodes. We've got one node, two gateway nodes, which connects to the outside world and provide inputs to your processing engine. So in a trading system, this might be orders and market data, or market data from a couple of different sources. This might be a matching engine or a strategy, and then it produces output which is fed back, in particular for, say, orders, and it's also picked up by these other systems. So what does that code look like? Well, that code looks pretty much like normal interfaces. And in fact, you can use these interfaces without Chronicle being there at all. And I encourage you to do that. Take your messaging layer out, prove your components all work without messaging. And then put your messaging in. If they don't work now, there's something to do with your messaging. But obviously, if they don't work without messaging, that's not the problem. The only thing that's additional in this is I've added a class called metadata. It's not required, but it's recommended because this keeps track of all of your timestamps in your system, all your microsecond timestamps, as you feed all the way through. So for example, I would have a writing timestamp here, a reading timestamp here, writing and reading timestamp here. It will get passed back to here. It might have a timestamp for going out, it might have a timestamp for coming in. Very first time, like a market event. But then as you get, say, a reply to your order, it might be another timestamp. And so your system's continually profiling itself and monitoring itself. You do this in a lightweight enough way that it has no impact on the production system, or next to no impact. You can see a complete history of every event as it passed through the system. And you've got a complete, precise picture of exactly what happened. And you can see where all the delays are occurring in your system, keep them all under control. So what does Chronicle need? Chronicle needs more documentation and tutorials and use case examples. At the moment, the best documentation is the unit tests, unfortunately, and examples. If nothing else, the unit tests at least work and are up to date. So, what is planned? Make it easier to use, improve text logging support, and one of the things I'm working on at the moment is a fixed, low latency fixed parser and writer. The aim of that is to be able to send messages and receive messages with less than 3 microseconds. Okay, questions? Does anyone want to see what the unsaved cast looks like? Okay. What can you do with unsaved? sun.miss.unsafe. What can you do with it? Well, you can read random memory by address. You can write random memory, you can read portions of objects at any type you want, write portions of objects. You can find where fields are in an object. It also has all the compare and set operations that are used in the atomic. You can access directly. But more interestingly, you can allocate an instance without calling a constructor. This is particularly useful if you're implementing some sort of deserialization. You don't need to worry about what constructors that class has. You know what values you want to give all the fields anyway. So you just create an instance and fill in all the fields. I think even now you can do this for enums if you want to create your own on the fly. It blindly throws checked exceptions, or there are other ways of doing this. There's at least 2 other ways of doing that. You don't need to use that if you don't want to. There's park and unpark, although you can use a class called lock support to get access to those. You can enter a monitor or exit a monitor discretely. This is a synchronized block. So imagine that a bit like a lock, you can say, I want to enter a synchronized block. And you can do that in one method, and then you can release that lock in another method. And even more interestingly, you can try to grab a lock. So if you want to go into synchronize, but you don't want to wait, you can find out whether you can get it or give up, try something else. It also has support for allocating blocks of memory, resizing them, and then freeing them again. These are used by the direct byte buffers, and I would suggest not using these directly. If you can, just use a byte buffer, because that at least makes sure that you will free it up correctly. No matter what happens in your code or if you have a bug. How do you get hold of it? Well, the only way to get hold of it is by a reflection. Assuming your container lets you do this, of course. If you've got a security manager, you might not, but once you've got access to that reference, you can use all those low-level APIs that come with it. The documentation's a bit hard to put on the screen because it's very long. A lot of methods are one-liners, and then they'll have pages and pages of documentation to say what it does. One of the things that's interesting is that even though they're native methods, they're treated as intrinsics. And what an intrinsic is that it goes and replaces the code with a single machine code instruction or a series of machine code instructions. In this case, it just substitutes them with single machine code instructions, which is why they're so fast, because they're about 10 times faster than a JNI call alone. So very quick. That's it. So is there any questions? Yeah.
Do you know if anyone uses Java Chronicle instruction system?
Yes, I have a couple of clients who use Java Chronicle. There's also a company I used to work for. They use something very similar, same technology, and they've been using it for 2 years in production.
And what exactly are their use cases?
Their use case was for a matching engine. That was the one that I mentioned, that matching engine had a microsecond round-trip latency. But other clients use it for general trading. The most common use cases, like I said, is just for normal logging, a replacement for logging, so that you can do it. You can log pretty much as much data as you like, and with as much detail as you like, and very little overhead compared to conventional logging.
What kind of messages can you write?
You can write text and binary. The type of message I don't suggest you write is plain serializable objects, because serializable is very expensive. It supports it, but serializing, deserializing an object is pretty bad. If you've got externalizable, that's dramatically faster, more than 10 times. I have my own form, which is called excerpt marshallable. That's about twice as fast as externalizable. Just because it provides access to the full range of methods that I have, whereas obviously externalizable has a fixed set, which is predefined by Java. So anything that's serializable you can write, and probably a few things that aren't.
So I read somewhere that using the Chronicle uses a single thread.
Yeah.
And doesn't let the operating system put this thread on hold.
Yes, that's a use case for using Chronicle. So if you're reading in particular, or even if you're writing to a Chronicle, the sort of environment this is typically used in is where you have busy waiting threads. And those busy waiting threads just continually are waiting for new work. And part of the reason for doing that is that you don't want to give up the CPU. If you give up the CPU, you lose your cache, and your code will run 2 to 5 times slower as a result.
Okay, so by default, it doesn't run like this on special pieces.
It doesn't have to run like that, but there's no particular requirement to run like that. But in its use case, if you're going to use build it around Chronicle case, then you will probably have busy waiting in your system. That's an assumption, but there's no requirement to have busy waiting. So.
A softball question.
Yes.
How can we get Chronicle and what license is it under? How much money do you have to pay? Do we have to pay for it?
It's Apache 2, and it's available on Maven Central. The only bit you have to pay for is if you want me to do some consulting in, but other than that, it's for free.
Have you tried running it with a run drive instead of a SSD?
Yes, you can use TempFS under Linux, and yes, it is quite a bit faster, right up to the point where you run out of memory, and then it's stopped.
How long does it take?
Not very long, unfortunately. You can use up 24 gig machine at home. You can use up all of its memory in under 10 seconds, and yeah, so it comes to a sudden stop pretty quickly because it's just so fast filling it up. So you're better off running it off to disk. The thing is, for bursts at a time, it will write it to memory anyway. You'll get the same performance. You just get more of the memory. And the buffers is usually about 10% of your main memory is available for buffers, where you get about the same performance. And at home it writes about 1.5 gigabytes a second up until the buffer fills up. And if you've got a box with, say, 32 gigabytes, that's about 3 gigabytes of data. Since it's fairly compressed anyway, you're looking at in the order of well over 100 million messages in that time. So if you've got bursts of 100 million messages, then that will fit into memory. But if you have longer bursts, then you're starting to be slowed down by your disk speed. So you can handle pretty chunky bursts of data and get much the same performance that RAM disk will. It's only when it goes beyond that that you see a significant difference.
Can you tell us a use case where you can use, in which you can use the replication?
You use replication for a number of purposes, particularly if you've got redundancy. So you've got a secondary system, you want to be able to take over from the primary. So you want to replicate in that scenario. You also want to replicate if, for architectural reasons, you've decided to have more than one machine and one communicates to another. So what you do is you effectively just replicate the file. So the file which you're writing on one machine appears to be being updated on another machine, and it uses replication to copy that data across. It does mean that every client that's on a different box and wants to get a copy of this stream gets a copy of the file as well. If that doesn't suit you, then I would suggest setting up some sort of gateway process that sits on the box, passes just what that process needs, doesn't require you to write the file. Also, you can replicate from production to test, and we do this quite often. So we have the production system running. We want to get some realistic data. We just tap a feed off, and we have running in test some real live data running in real time. It's also very easy to write a little component. Because you're recording everything, say, from the start of the day, you write a little component that instead of replaying it in real time, replays it 10 times normal speed or some multiplying factor. And so it runs through the events. So you get realistic data, but rather than wait around all day to see if, how long it's going to take, you run it at, say, 10 times normal speed, and you get through a lot more events much quicker.
Does it export any internal statistics via JMX or some other way?
No, not currently. Yeah. You could probably add that, but generally for monitoring, you would just look at the file, because you can read everything it's doing by reading the file, rather than getting the program to export that information. Part of the reason why I tend to avoid JMX in low latency systems is it creates quite a bit of garbage, because it uses normal Java serialization, which is terrible. In fact, if you use Visual VM on an idle process, you will see that it's continually GCing, and you get this sawtooth pattern. And that's because there's so much overhead in just polling JMX asking what's the state of the system, that even a system that's idle will show you a nice sawtooth pattern.
Is it possible to add transaction support to Chronicle?
Well, it has transaction support in the sense that when you call finish, that's it, it's written. Even if your process dies, that has been committed. It also has another mode where it not only goes committed to the OS, but is committed to disk. Quite a bit slower, but it's entirely dependent on the speed of your drive. On a disk with a file cache system, we've got about 20,000 a second. With an SSD, you should be able to do more than that. But I'm not sure people use SSDs in enterprise, that kind of an enterprise scenario.
Do you plan to add in the future a functionality where you specify this maximum size of your logic file and then automatically write over it from the beginning, like in a ring file, for example?
Not really. The part of this philosophy is that you have more than enough free disk space. And disk space is pretty cheap. I mean, a 1 terabyte drive is well under £100. So recycling that 1 terabyte drive can be reused every day anyway. So adding the recycling facility doesn't really help very much.
It requires a minimum manual labor.
Yes, it's actually quite a lot more than you might imagine, because part of the reason it is so fast is because it never writes to the same memory twice. Writing to the same virtual memory twice requires all sorts of other guarantees, like memory barriers, that this program doesn't need to do because it's only ever appending. And this is why this is up to 8 times faster than using IPC shared memory. Right? So that's shared memory written in C, written as part of the kernel. It's been standard for many years, used by most commercial solutions. And it's up to 8 times faster because it never has to recycle its memory. And it's an issue it never needs to worry about. And so you get much higher throughputs as a result. Your cost is you waste a bit of disk space potentially, but it's something you can reclaim every day anyway.
And another question, the last one. You said that you needed some help in writing more documentation, tutorials or something.
Yes.
Did you thought about the idea of using, I don't know, Google Summer of Code, for example, to gather some students and work for you by Google paying for that? Because you're an open source project.
Yeah, I'd be happy to do that. I have done that in the past, actually, on different projects, but I found that the amount of time involved in getting them to do the work satisfactorily exceeded how long it would have taken me to just do it myself. And I think that's as much a failing on my part as it was on theirs. So yes, I'm more than happy to do that, and I'm more than happy to provide some funding for people to help. I just got to figure out how that would work and what would be the right model.
Actually,
and perhaps if people have done this before and seen it work, I'd be very interested in their ideas.
Using Google would mean that Google would pay for the people and you would just get a benefit.
Oh, okay.
Quick question about application. Is application push or pull? So when you have application, do you have to know beforehand how many replicas you have, or at any time can you start up a replica and say, now replicate what's being done on that node?
It's entirely pulled. So the sender has no idea how many consumers there are, and it is not slowed down by the consumers, because there's another reason it doesn't recycle. Because if you start recycling, you need to know that all the consumers have got a copy of the message and you don't drop any messages. Whereas it just keeps all the messages from the start of the day. That means that even at the end of the day, you can attach a replica, come in that was never there before, get all of the messages from the start of the day. And that's a practical consideration because you can run through the messages so quickly. You can do many gigabytes of data in a matter of seconds, replicated to a second box, maybe in a matter of minutes. And you can do this at any time before you rotate the files. Once you rotate the files, obviously it becomes a much more complicated exercise to get copies automatically. But up to that point, you can attach. So that means that your consumer can be down for hours at a time. And what it does is when it reconnects, it says, I'm up to this message. Can you send me everything from this point? And it will just it will replay it at that point. So one of the key things about this design is that the consumers can be any amount behind the producer, although it's assuming that you've got a daily cycle or a weekly cycle. So that means that your producer will never be slowed down by a slow consumer. It just doesn't care. It means that the consumer can be more than your main memory size behind your producer, right? Which is another thing you can't do in any other Java implementation I've seen. So the consumer can be just ridiculously behind. It can be, and it doesn't matter. Well, it has an impact, but it will all work and not cause undue impact on your performance.
Is it easy to create a feature or update a project to something like that? I'm writing summary on the disk, everything that I want, I'm going there, and at the moment this disk is full, I want to write the rest on other disk, let's say, something like that, or maybe network, whatever.
You could do, but again, I would try and work on the assumption that cost of the disk is far less than should never be an issue. The amount of disk space. I know in some companies they treat every gigabyte as being like gold, but that doesn't mean that it really is worth that much. And so I've always pushed back and said, well, look, how much is this? Give me a realistic price of what this disk space should be costing. And the other thing is that even though I mentioned a terabyte, a lot of these systems, because it is quite compact data, you're looking at maybe 10 gigabytes at a stretch. I had one client, they were getting about 3 gigabytes a day, and they were cycling every week. So it's getting up to about 20, just over 20 gig in a week. It's not. That sort of space really shouldn't really be an issue.
I was thinking more if you have a system that you have to write a large amount of data, let's say 1 tera, counts data, and maybe the consumers cannot keep so fast with this data. Yeah, so the consumers can't consume everything that I wrote, but the producer should produce continuously. One part is full, I want to go to another one. So.
I could get a 2 terabyte drive. It's less than, because a 2 terabyte drive costs less than £100. You know, it's not big money. If you're dealing with that quantity of data, you know.
Okay, but yeah, because I don't know now the biggest hard drive is 3 terabytes. I think you can do a write 6. Okay, I don't know if you can put more than that's full.
Well, a 1 gigabyte connection can only do 10 terabytes in a day. That's flat out, 24 hours a day, 1 gigabit. Sorry, you can only do 10 terabytes. So yes, I mean, yeah. The thing is, you don't have to write everything to the same file, right? You can have multiple files, which can be writing to multiple file systems, and you can have multiple servers, and they can have their own local desks and so on. But you find that usually there's some other limitation, some simple hardware limitation, which will hold you back from going any further. It really is designed to work at the limits of what your hardware can do. And you find that there are other solutions. Not every solution is solved by software. Sorry?
Unless you're using fat, maybe, then you can't go over 2 gigabytes of file.
Yes. That's true. There are some file systems that only handle 2 gigabytes, in which case you would have multiple files. You would have to have multiple files.
Yeah. I've got a question. I saw that you have a class called indexed chronicle.
Yes.
Does that mean you can do queries on it?
The only query you can do on it is look it up by index.
Okay.
So imagine it gives you all the functionality of an open-ended array or array list. So if you want to do indexes, the simplest thing to do is to create a map of whatever your key is, to an integer or a long, which looks up the entry which has got all the value details you want. You can use something like trove to make that slightly more efficient, because your value is not an object. And I have implemented hash tables inside something like Chronicle memory map files. But to be honest, it is such a pain. You're better off, much simpler to use the heap and use a map structure in the heap. You would only use a Chronicle-based hash map if the keys were very large compared to the size of the values. Because, whereas if you've got small keys and big values, this will work brilliantly, that combination.
You mentioned at the beginning that this is GC3. Why is that important? We are all Java programmers and GC is our friend.
Yeah, GC is your friend up to a point. Some of the things that you don't need this anyway. Some of the reasons for avoiding GC, the most obvious reason that people cite is reducing full collections. Full collections can take in the order of seconds, and for large heaps can take close to a minute. And no matter what your application is, GCs around a minute are painful. So if you reduce the amount of garbage you're producing, you have less pressure for objects to go through all of your Eden space, Abida space, and end up in your tenured space, and then get cleaned up by a full collection. Less pressure means that they're more likely to die younger, and you're less full collections. And in many cases, most trading systems, their objective is no full collections at all during the day. I go a little bit further than that, a bit more extreme, and say no mining collections either. The way I achieve that is I reduce the garbage to the point where it's smaller than the Eden size. So one of the trading systems I developed, it produced up to 8 gigabytes a day of garbage. So what I did was I created the Eden size of 8 gigabytes, and slowly over the day you could see that it was slowly filling up the Eden, and then at 5 o'clock every morning did a full collection and cleared it off, and then got another day's worth. So no minor collections. More recently, that was before I had Chronicle. Now with Chronicle, most of the data and logging goes in there, and as a result, heaps, the Eden sizes are usually less than a gig, and even then it still doesn't micro. Now, why is this important? Because one of the things that the guys from the Zoom will tell you is, oh, we've got a concurrent collector. You don't have to worry about jitter, and you won't have to worry about the jitter caused by full collections or minor collections. Well, the problem is that one thing they don't solve is, you're creating garbage so fast, you're filling your CPU caches with garbage very quickly, very often. If you're producing 32 megabytes of garbage, your L1 cache is being filled literally with garbage every millisecond. So if you try and access something you accessed a millisecond ago, it's gone. You just wiped your cache with garbage, your level 1 cache. Now your level 3 cache is quite a bit bigger. So it might be, say, 10 megabytes, which is quite a lot more than 32K. Or if you get a high-end server, 24 megabytes. But say you're producing a gigabyte garbage a second, that will be filled in about 40 milliseconds. So very quickly, that will be filled with garbage. And what that means is your program is now going to main memory. It's either going to L3 needlessly, or it's going to main memory. The difference is that if you're hitting L1 cache to hitting L3 cache, is the L3 cache is around 5 to 6 times slower. So your program is going 5 to 6 times slower because of the amount of garbage you produce. Every memory access is 5 to 6 times slower. If it's going to main memory, it's going to be 10 times slower. Right? So a lot of this effort you went to make your program multi-threaded and all this other stuff, it's been thrown away by the fact that all your threads are all hitting L3. There's only one L3 cache. There's only one bus to main memory. They're all being funneled into this single-threaded resource that is now running much slower than you would otherwise do. So one of the things you find is that when you reduce the amount of garbage you produce, it runs a lot faster. And I've got a blog entry where I talk about serialization and deserialization. Now, one of the things I don't mention in there is the entire difference between the deserialization I use in Chronicle and the one that Cryo uses, is that it is just as efficient. The size of the message is almost exactly the same. One thing they don't use is object pulling. They create new objects all the time, and that kills their cache. And the difference is a factor of 4 in terms of the performance. And yet they're doing basically the same thing, basically the same way, but what they're missing is they're creating new objects every time. And obviously in the benchmark, you get brilliant cache hit rates. So the difference is much more stark.
So maybe a follow-up on that, what kind of techniques, in a few words, what kind of techniques can you use to make your system GC-free?
Well, GC-free is probably a rather ambitious goal. Usually to make a program properly GC-free, it has to be built GC-free from the start, from the ground up. So that's probably not practical. What you can do, however, is you can use a memory profiler and attempt to reduce the amount of garbage and the amount of memory you're using. The other thing you can do, which I find is a good trick, is you enable memory profiling and CPU profiling at the same time. That will give you, in your CPU profiling, basically a little bit more weight to all of the memory accesses. And that often shows you methods worth optimizing that didn't show up before. And so first protocol is have a look at the memory profiler. And that can help you improve the performance, but also reduce your GCs. But not only does it reduce the stop times, but also the code, even in between GCs, will run faster as a result.
Do you have any recommendation regarding database access? I'm referring to prepared statements, for example. Might fill up your...
apart from making sure you always close them.
Okay, yeah, but
yeah.
If there are cache in memory, for example.
They're a little bit different because the main delay in prepared statements or accessing a database is just the sheer I/O weight. Certainly for simple requests. For long requests, you're entirely dependent on what your database does. It's most likely, it's the certainly in the systems I do, I don't worry too much about the JDBC because I externalize that. So I have that as not part of the critical path. And then even in that situation, it's usually the database that's the slowest bit. So there are lots of things you can do to tweak the Java side, but whether they really make much difference at the end of the day, compared to how much delay you have in the database and your network, I'm not really sure that that's, you would have to test that to see whether it really does make a difference. A lot of things that should make a difference in theory often don't, or often do the opposite of what you think they should. And so I'm a strong advocate of always measure your optimizations, because so often you're wrong, even if you're an expert in the field. And it's one of favorite quotes of Kirk Pepperdine. He's been doing tuning Java systems since the 90s. And so he's been doing it a long time, and his favorite quote is measure, don't guess, when it comes to performance, because even he finds that so often what you think should be the case in terms of something being faster is not the case. So in the absence of any information, I go back to my original statement. If you don't know for sure what's faster, just make it simple, and then it will probably be fast enough.
Another question. You mentioned that you can make the finish method force synchronization with this.
Yes.
Can you do something similar if you synchronize the TCP from another machine?
No, although the simplest thing to do there is that if you've got two machines and that you want to wait until the second machine receives data before sending back a result, is you have the second machine do the result. So your first machine has a copy, it copies to the second machine, and only when the second machine gets that copy does the result go back. If you really have to, you can pass it back to the first machine and send a result. But if you just have the second machine send the result through some messaging system, then that solves that problem. Then you just have to think about what happens if one of the two fail. How do I keep running? Because obviously they both have to be running for that to work. But it does that has been used in the past. I've done that to make sure that that there's always a redundant copy between two machines. So that even if one machine blows up, the client won't see anything that hasn't been preserved on at least one of the machines. In that situation, don't put the machines too close to each other.
You said that, don't guess.
Yes.
When you do benchmark, you use some kind of framework that's available for party or something like that, or just create your own?
I tend to create my own because I've been doing it a long time and I tend to tune it for the use case. But there are a number of good benchmarks out there which will probably suit most people. The most obvious one is Caliper. That's been around for a while. There's also a Java micro benchmarking framework, which is more recent. That looks very good as well. So you consider either of those, and both of them work very well except in sort of fairly extreme cases. They're good, they give a good indication as to performance. The thing about micro benchmarks is that they can vary so much from one machine to another, from one version of Java to another. And so unless you see a big difference, then I would take it with a grain of salt. So if you see a difference of 10 times, it's usually my rule, then that's something you probably want to think about seriously doing something different as a result. If you see a difference of 10, 20, 30%, you still go back, I go back to my rule of what is simpler. Because before you know it, that 30% has disappeared because you ran it on a different box or the version of Java upgraded, and your entire, you wrote all this complex code to make it faster, but in reality, it wasn't working.
Are there any similar libraries in the open source space to Java Chronicle? And if yes, how do they compare?
Closest is Disruptor. And to some degree, some of the ideas, particularly in terms of memory barriers and so on, were taken from Disruptor. Disruptor is even faster, quite a bit faster actually. And so from that perspective, it has some advantages. It also supports multiple writers without locks, which also is very nice. It has a few disadvantages. One is that it uses a ring buffer, which you have to tune the size. So it's a bit of a problem for Goldilocks because it's difficult to make it small enough so that it's efficient and stays in cache, but not too big, not too small that you won't stop the producer because it's a slow consumer. The thing is that in almost all trading systems, at some point you want to persist all your data. So it doesn't solve the persistence problem at all. And in the end, you end up having to put in persistence. And in many cases where people have used Disruptor with Chronicle, they've ended up saying, well, why do I need Disruptor really? I'll just use Chronicle. The other problem with Disruptor is that you have to pre-allocate your objects. So every message in your system has to be the same, or is it you have to create a sort of a super message that has every possible field you might need, which is perhaps not as elegant or efficient. Chronicle doesn't require every message to be the same type. It just needs to be serializable to a series of bytes, which is a different requirement. But then you kind of need that if you're going to have any element of persistence or any element of it being copied across the wire anyway.
Can you do some code change to the sample and write 5 random numbers so we can give the licenses from the audience?
Not sure how you would use, yeah, we can use 5 random numbers. Do you have a range for a number?
Yes, 1 and 90.
Between 1 and 90. There's 5 of them.
Yes, 5 rounds.
Test this works first. Yeah, got 5 answers. So between 1 and 9. There you go.
Do we have any high costing? No? Okay. Ovidiu Bertila? Okay. 6. Vadim Moradziu? Here. Okay. Winner. 12. It's yeah, unfortunately not here. So 90 is Mihela Flora. Okay.
So do you have the email addresses for these people?
Yeah, you can type in there. Can you type an email address so they can contact me? Or yeah, let's take it offline.
Yeah, definitely. Yeah.
The procedure is that I get your email addresses, I forward them to the YourKit guys, and they will send you the licenses directly. The licenses are good for 1 year. It's a personal license. You can use it for anything you want. And I think we need 2 more random numbers then.
We will have 2 emails on the list.
Can you use it in a job?
Yeah, you can use it at the job. So you can use it for 1 year for whatever you want. Like,
Let's run it again and we'll find the numbers.
this was from the next one.
Bogdan je good.
This is Ichecka.
I on Sabin?
Okay. Two.
Diana Kikesh? They didn't know it was a Friday. 74. Daniel Nemes? So Peter, thanks for your time, thanks for sharing this with you.